Today we will be discussing very important topic in regard to organic chemistry. A topic is named as leaving group tendency. So if I talk of organic reactions, primarily broadly I can classify organic reaction into three categories: substitution, elimination and addition reactions. When you talk of these two reactions, substitution and elimination reaction, in these reactions you are going to add something into the substrate. As a consequence of that, from the substrate something leaves out, and that is what you call it as leaving group. And as a matter of fact, if I would show you that if there is a substrate, into this you have attacked with some attacking reagent, as a consequence you get a product and leaving group departs out of the system, that particular type of a reaction is called as substitution reaction. Here in this video we will primarily be discussing the nucleophilic substitution reactions. Nucleophilic substitution reaction, in those the nucleophile is the attacking reagent and it attacks the substrate, and as a consequence you get a product and leaving group departs. Let me show what I am trying to say. Say for example you have a polar carbon bromine bond, and in this is your substrate, which is the organic moiety on which this reagent as a OH negative or a nucleophile attacks it. As a consequence, Br negative goes out and you get a alcohol. This you get a alcohol and Br negative goes out, and this Br negative is called as leaving group. So leaving group tendency, if the departing thing leaves the reaction system very fast, we will be saying that particular substrate is very useful for making different types of compounds, and that is why we used to study alkyl halides. In alkyl halides, the leaving group is the halide ion, which is a good leaving group. And why is it good leaving group, we are going to discuss in a while. So that is why we used to say alkyl halides are very good starting material for making different compounds, because the halide ion can be displaced by most of the nucleophiles. Let me show you few more examples here where I am explaining what is leaving group tendency. So here OH negative is attacking this carbon delta positive delta negative polar compound, and this goes out, and as a consequence you again get alcohol. Along with it you get a leaving group which we shall be saying it as triflate ion. This is a very good leaving group. Why is it a very good leaving group, we will be discussing in a while. Similarly, if you would just treat amide ion and would attack this bond, this attacks here and this goes out, and as a consequence what you would get is a acid amide along with acetate ion goes out as a leaving group. So I shall be saying this as leaving group. This is your substrate, this is your substrate, and this is your attacking reagent, which in this case is a nucleophile. Similarly, if you have some elimination reaction, there also you would get to know about the leaving group. Say for example alkyl halide is being treated with alcoholic KOH. Here OH negative would take out this H positive, that is alpha beta hydrogen, and this bond goes here and Cl negative goes out. As a consequence you end up getting an alkene. Along with that Cl negative goes out of the system. This again would be said as a leaving group. So this is one of the example where we talk about the elimination reaction. During general elimination reactions we tend to create a new pi bond in the product. So this you always have to keep it in mind. Sometimes the leaving group could be a gas also, just like in the pyrolytic elimination of beta keto acid. If I would write this alpha, this as beta, this is beta keto acid. So if you just would heat this beta keto acid like this, and you happen to see carbon dioxide goes out of the system, and you end up getting some ketone, and the reason for this is the chelation or the 6-member transition state which has been generated here, and this happens to create a H bonding here, and as a consequence you happen to get a the driving force for this reaction definitely also is the fact that the leaving group is carbon dioxide. This CO2 molecule goes out of the system and then it tautomerizes to give you ketone. So there we will be saying this is our leaving group. And similarly, if you diazonium, aliphatic diazonium salt is being heated with OH negative, this nitrogen goes out as a gas as a leaving group. So we shall be saying this is also a very good starting material for making different compounds, because those reactions in which the leaving group is a gas, that also is very favorable. Now here we have to understand why what type of entities we shall be saying it as a good leaving group. So we know the fact that if I just would say this as to be acid, So acid loses H positive and this is its conjugate base. A negative is conjugate base. And if I do write it from the equilibrium expression, I shall be saying strong acid definitely would have high concentration of H positive. So Ka would be high and Pk will be less for that. And when you talk of a weak acid would have lesser H positive, and as a consequence Ka, dissociation constant of that acid, would be less and Pk will be more. So this I know for sure you people are aware of the fact that strong acid, if I would now write it in a conceptual way, strong acid has a stable conjugate base. The conjugate base is stable. If this entity is stable, this equilibrium would be forward driven. Okay, so if it is forward driven, we will be saying it's a strong acid. So I am saying strong acid has a stable conjugate base, and stable conjugate base is a weak base, because if it is stable, it would have no tendency to go back. If this entity is quite stable, it has no tendency to go back. So we will be saying stable conjugate base is a weak base, and weak base is a good leaving group. So wherever you would find a, if I consolidate these three lines in one statement, so I can say conjugate base of a strong acid is a good leaving group, because when the acid is strong, its conjugate base would be stable, and if it is stable, so that particular thing when attached to any substrate would want to come out very easily. What I'm trying to say here is, let me explain what I'm trying to say, that if I have with me, say for example, this compound, and if I treat it with OH negative and throw this out, what I shall be getting here is alcohol along with I negative. Now I negative is a conjugate base of a very strong acid Hi. So Hi is a strong acid for which its Ka value is high, Pk value is small. So Hi is a strong acid, so its conjugate base is stable, and this entity containing negative charge always would want to come out as I negative. Once it came out as I negative, it has no tendency or lesser tendency to attack the substrate or the product once again. So we shall be saying this has to be a good leaving group. So here is the list of which many of the students have asked. Here is the list which I have made, that what type of entities are called as excellent leaving groups. Leaving group, those entities, those anionic species are good leaving group which are the conjugate base of a strong acid. This point you always keep it in mind. And first I would say, whenever any system leaves out gas like nitrogen or CO2 or carbon monoxide, if gas is a leaving group, that reaction is highly forward driven. Second is, this all I am writing, these are very good leaving groups. So first of all is called as mesylate. This particular species is called as mesylate, and this is called as triflate. Why these are strong good leaving group? Because the negative charge got stabilized on both of the sulfur oxygen bonds. So these are the conjugate base of a very strong acid, which we call it as sulfonic acid. Sulfonic acids are considered to be strong organic acids. Similarly, these are the entity which you should always remember. They are quite important. If I would place CH3 here, then this would be called as tosylate. If I would write bromine here, so it is called as brosylate. And if I would write NO2, which would make it strongly electron withdrawing and would stabilize it very much, it is called as nosylate. So all of these are good leaving excellent leaving groups, because these are the conjugate bases of a strong acid. Now if I would write some good leaving groups can be considered as I negative, Cl negative, Br negative. These are considered to be good leaving groups. And if I would say fairly good leaving groups or fair leaving groups are water or ammonia or acetate ion. These are good leaving groups, fairly good leaving groups, because water, if it is a neutral entity, which would come out as a good leaving group, and water would come out only if during the reaction you have this sort of a entity attached somewhere. So this can come out as neutral water if nucleophile attacks this and this goes out as water. So then only you would get this entity. Similarly, if I would write poor leaving groups would be considered as F negative, OH negative, OR negative. In fact, these are strongly basic. And similarly, very poor leaving groups are amide or substituted amide or carbanion R negative, carbanion or H negative or AR negative. These are considered to be very poor leaving groups. So these are the list of some of the things, and at times you would also see somewhere H negative is written as a leaving group. H negative rarely comes out as a leaving group except in the case of Kenny-Zero reaction. If you could remember from the +2 organic chemistry, in the Kenny-Zero reaction, mechanism shows that OH negative first attacks the aldehyde without alpha hydrogen, and this bond goes here, this gets a negative charge, and then this throws out H negative, and this H negative when comes out, it attacks the another mole of this. Here we will say this is coming out as H negative. H negative as a leaving group is attacking onto the next entity. So this always you have to keep it in mind. So here the compound formed as O negative H, and along with you would get carboxylic acid. So carboxylic acid along with alkoxide is a strong base, it would abstract the H positive. Ultimately you would get a compound of this nature. This Kenny-Zero reaction is being given by aldehydes without alpha hydrogen, and it is mainly a disproportionation reaction where aldehyde happen to change into alcohol and carboxylic acid. So this is somewhat about the leaving group. Hope you have understood the fact that I just would write once again, conjugate base of a strong acid is a good leaving group, and vice versa. If you would do the reverse way, if I would say conjugate base of a weak acid is a bad leaving group. So make it a point, this is the main statement, you always keep it in mind. Hope you have enjoyed today's session. Hope to see you in the next video. Bye bye, take care.